Hello, I hope that you are doing well. Today, we will create a a table and insert millions of data into it, and to find from the, for example, primary key and non-key attributes with manually and with the help of indexing processing, which is consist of um, hash indexing and B plus tree indexing. I have already assignment 2, and let's, for the time, so for the not the long time, I will write this, copy this. Let's look. We have ID as a primary key, number one, number two, text one, text two, and date field as a date. The most of them are randomly picked from the millions of data. When we insert the millions of data to our database, and let's create a table. Now we have uh, already a table, as you can see. Yes. Now we will. Yes. Now we will insert to our table millions of records with the help of actually MD5 random text um, engine that produced many random uh, texts or other things uniquely. Yes, let's run it. It will take a time. Yes, as you can see, um, we had millions of data, and to show it, we will write the code select all from our table name large data. Select from large data. It will also take time. Yes, as you can see, we have a millions of data. It is visible now, and let's took some value from it. And for example, to find the ID, where uh, just to show the column to find from ID. Yes, now right select from from our table name data where ID um, where ID is equal to, for example, 4295. Yes, yes. Now you can see the column, the full column, which we referred it to find to ID. It shows the number one, number two, text one, text two, and data for field. Actually, the ID is the primary key. That is why the time is less than to find others non-keys. Uh, Now let's find the others, select from large data where, for example, text1 text1 is equal to, let's write this, copy this. It is 1.2 second, and now we will see this. Let's write it with that way. Now, sorry. As you can see, it takes much more time because it is non-key attribute than the ID. We had 1.2 second in ID, but in this we have around 7 between 6 7 minutes. Let's write other. Let's write for other attributes. Select from large data where, for example, let's write date field is equal to this. Let's write it in the let's run it. Yes, this records actually in the one in the, for example, this time there can be many records, and the list of records are shown here. As you can see, it is the time is also much more than when we find refer to ID, the time. Yes. Then we can find it also for number one. Let's write, copy this. Where now one is equal to, for example, we can take this. Yes. Now run it. Sorry. As you can see, we show the columns, and um, the time is also much more than the ID when we find the ID. Yes, now we can um, take return to the indexes. Yes, when we write this with the firstly hash indexes, firstly the we will talk about time dependency. we will compare the times, execution times, and we will see that how is helpful, how the hash index is helpful for us. Now we will write the structure of writing hash index for create our table. Now let's write create index uh, index yes index hash. Let's write hash index hash text for first the text one on our table name large data with the using clause hash hash and text one yes create index on large data using yes. Now let's create our hash index. Firstly, it also will take time, but then it will be helpful for us to find um, in a to find any attribute in a short period of time. Let's wait. Yes, we have created our first index, and then we will create the others for the other attributes. For example, it will be number one, and it will be number one, create index, number one, data, yes. Then we will create data field, in the data field, date field. Yes, our second index is created. Then let's create the other index for the date field. Date field. Yes. Let's create this one also. Yes, we created the third index. Now, let's took this, refer to ID, find. Yes, as you can see, in the first, when we do it manually without um, indexing, hash indexing, it took 1.2 second. But now, as you can see, it took 1 point um, near to 20 millisecond. Yes, let's write also for we created is num1. Let's took this as you can see. It's too short time. Also for data field, yes. I argue that the creating of index takes around 1 minute. The process takes around 1 minute, but for the huge amount of record, it is um, available. It is needed for to find one record. Um, for example, in second, 2 second, or in 0.20 millisecond. Of course, it is better. The second one is better than first one. Yes, we. I think I explained the role of hash index, which is related to time dependency. Now, let's firstly drop our hash indexes and take turn to the a plus 3 indexes. I will explain the differences between them at the end. Yes, let's write drop index, the name index hash text 1. Yes, then drop index hash um, num number 1, number 1, yes, then drop index hash date field. Yes, for the creating and to see the effect of cluster indexing, we should drop the hash index from our table, and let's write the structure of uh, the cluster indexing. Create index um, index um, bit3 plus 3 bit2 for text 1 on our table name large data Yes, large data using p3. Yes, text one. Create index. It will also take time. Actually, for the time dependency, of course, the hash indexing is more uh, efficient because the time is less than p plus 3 indexing. But there are other differences that uh, we will talk about during the video. Now let's wait for creating index. Takes a lot of time. Yes, we have created the p plus 3 index and let's select our this one, copy and execute. As you can see, it is, I argue that it is, when I said that it is, the time is more than, much more than hash indexing, but this indexing also helps us uh, to find the record um, fast than do it manually. Yes, let's write this one in the our other for our other attributes. Create index. Let's write for uh, date. We can date filters. Date. Yes, date filters. Date field. Date. Daily characters. Now let's execute. Sorry. Yes, as you can see, we created this index also in 14 seconds. Now let's we have data field. For example, let's took this and execute to check. Yes, also it is in millisecond. It is more efficient as you can see. Then we will create another indexing and number one. Let's text one number one. Text one number. Let's execute. Yes, as you can see, we also have created this one and num1 select from, let's take this. Mm, Let's execute. Yes, as you can see, again, it is in millisecond to find it. Yes, as you can see, I showed the hash indexing and B plus 3 indexing with the examples. Yes, now let's talk about some key differences between the hash indexing and B plus 3 indexing. As we mentioned before, in the hash index, the time is less than, it's more efficient, by the way. Time is less than B plus 3 indexing, and but in huge data, B plus 3 indexing has more good sides. For example, in the ordering or between some numbers or alphabetic ordering and so on, B plus 3 is more efficient. Let's try uh, one of them. Right, select all from uh, our data name, large, our table name, large data, where number one, where number one between, for example, and for example, let's write let's write this. Let's try this. Yes, as you can see, we found the list that number one is between these numbers. Also, we can write select all from wait, select all from large data order by text one with ASCII Yes. At the end, I want to say that hash indexing typically offers constant time for exact matches, but it's not more suitable for the P plus 3 indexing because the P plus 3 indexing provides logarithmic time, and in the ordered access, P plus 3s maintain a sorted order among keys, making them too suitable for ordered data. But hash indexing doesn't inherently maintain any order. That is why it's not efficient. Then about the storage overhead, hash indexing typically requires less storage overhead per entry compared to B plus 3 trees because it doesn't need to maintain pointers to other nodes. Yes, the main differences are they. Thank you for watching the video. Have a good day.